Hi there. Today we're going to explore data and statistics and some regression graphs using an activity that is a STEM-related activity. So we're really focusing on force and velocity. I'm using Classpad.net. It's a free, web-based, all-in-one software tool, so you can do calculating, graphing, geometry, statistics. We'll be doing some calculating, graphing, and statistics in this, so you'll see a lot of the action. It's free, and so the activity I'm sharing, which is in the link below, you can use without having an account, but I would suggest create an account, free to do, and that way you can save the activity and add your own questions and whatever you might like to it. So I'm going to go into the activity. I just click the URL link, and it brings up the activity that I see here. And you'll see it's... move things out here. It's basically, it's kind of strange size just because of the sizing that I have. I'm working on a small screen right now. But basically you'll see this is a text box, and it's kind of talking about what this activity is focused on. So acceleration, force, inertia. And this is an activity where you could actually have students do it. So you'll notice there's a picture here that kind of shows you what the activity is. It's a straight line. You're using a frisbee, a disc, or something that you're going to be pushing. So it's starting from a static and inert position, and you're going to be pushing it with different levels of force. And each person here is at a specific part on the line, right? So 5 to 6 feet apart, and they each have a stopwatch. So start time, everyone starts at 0, and then this person is pushing with whatever the designated force is. And as it passes each spot, that person stops their timer. And so then you record the time at each distance. And so you could do this with students, right, if you actually had all these materials. But if you didn't, you could still talk about what's happening. You could act it out, whatever, but then here is actual real data. So we have some sample data that we're going to use. And so the first thing they're asked to do is to compare. So notice that they do the same path 3 different times. So with a light push, a medium push, and a hard push. And we're really exploring, you know, did they go faster, which seems to make sense, but let's look at their path, and then we're going to explore velocity. So let's just real quick, first thing they're asked to do is make a scatter plot and compare them, and then do a regression, so basically see what that rate is. So I select the 2 columns, so distance and the light push is my first scatter plot, and here is where I have graphs. So this was data that was collected. I'm going to hit graph, and now I can make a scatter plot. And so what you'll see is a scatter plot, a scatter plot, let's move that back up here, of that first path, right? So pretty constant, right? If they were doing a pretty good job being constant, so that means at each distance they're going about the same rate. Let's see if that's true for the medium. So let's do medium and scatter plot. So we're going to see a different plot. So it also looks pretty constant, but it's not as steep as the first one. So what might that mean in context? And so now let's do the last one and scatter. Whoops. It made a same scatter plot because I didn't connect. There we go. And hard and scatter plot. So, oh, that's not a good color. So if you don't like the colors, this one was a repeat, so I'm going to get rid of that one. Let's change this color to be something that stands out a bit more so we can compare them. So notice I now have my 3 scatter plots. So first one for light, then the medium, then the hard, and so each color corresponds. And so they all look like the person pushing was doing a pretty good job with being consistent with their push. But the faster one, obviously less of a line, less steep, but they do look linear. And so then the next thing they're asked is, okay, explain what these mean. So we notice we have a place for them to write their directions. And now let's make a regression. So a regression using the Classpad data is just as easy. You're going to select the same things in the scatter plot, but instead of a scatter plot, I'm going to hit this back key, and I'm going to go to regression. And notice I have a lot of different regressions. We're just going to go with linear. And so it's going to put a linear line through that. And what we then can do is look at that regression, and we could even change the color to match the points. So it's blue. But what does that mean? So A represents the slope, right? So they were going, what does that mean in context of this situation? That might be their push, those types of things. So now we're going to do the same thing. So the first thing is, what do these slopes and these intercepts actually mean? And then, so I'm just to create the regression, you select the columns again, just like you did for the scatter plot, but you choose linear regression since they look constant here. And again, you can change them to match their points. We tend to like to be consistent here. So that last one was green. And so now you see that it's constant. What's that mean in context? Does it make sense? Do they go through 0? Those types of things. So this is what it looks like just from the push. But now we're going to take those times. So here's the distance. So if you look at the distance, every 5 feet we are recording time. And so velocity is the distance covered. So if you look at it, distance covered and the amount it took to go that distance. So every time we are going 5 feet. So the distance is the same, but what is different is the difference in time. So when we come down to this table, and what I wanted to show you, the nice connection here. So here's the data, but I now have a new table, and notice that same data is in my table here. And what I'm going to do is, oops, I think I have this in the wrong place. Let's hit enter. There we go. Hard. They're all connected. And then this, I want to delete these numbers because we haven't calculated that yet. There we go. So notice these are the times at each distance. And what we're going to do is now calculate the velocity, how fast each distance, each 5 feet actually took. Were they going the same speed, velocity? So to do that, it's distance. So each one's 5 feet divided by time or change in time. So I'm going to just show you how I would calculate, and then I'm going to pause and calculate the rest of them. So I'm going to get a calculator sticky up here. So they notice over here in the directions, it has kind of an explanation of what distance is, a hint, a reminder, and then so a reminder that in this particular experiment that each distance covered was 5, but you need to take the time at that interval and subtract the previous time because that will give you the time at each separate 5-inch. So what that means is, and let's just look at the light one here. So in this very first one, that was the first time recorded. They only went 5 feet, and then I'm going to divide by the time it took to go that 5 feet, which was 2.6. So my velocity for the light push in that first instance is, and let's just round to tenths here, is 1.92. Now when I want to record this time frame, I'm still only going 5 feet. From this time to this time, I've only gone 5 feet still, but my time that it took to go this second 5 feet is the time that I'm at, 5.3, minus the time I started before. I started from the last interval at 2.6. So the velocity here is different. So 1.85. And so we're going to be doing that for each one. So if I now want to go look at the third one, I'm going to take the same distance. They're all 5 feet, but now it's the 8 minus the time from the previous where I started it. And it's pretty close. Like those are, which means their speed's pretty consistent here. And then we're going to keep doing that. So I'm going to pause this real quick and do the rest of the table so that I'm not taking up time doing that. And then we'll just talk about the plot. All right, so you're back. I'm back. And you'll see that I've calculated. And what I really like this is I started a different calculator sticky for each set of calculations. So it's a nice way to show work. So here's all the work that was done for, say, the hard. You'll see that I took each time, divided by the distance that it went, and did the difference of times. So you'll see where these calculations came from. And I have one for each of them. And so this is a really nice way for students to be able to show all their work. It just stays here. And then I can kind of put these out of the way. The next thing they're asked to do is then, okay, let's graph time versus velocity, right? Their speed. So let's do that now. So we're going to take the time for the light push and its velocity that we just calculated, and we're going to go and hit graph and do a scatter plot. And what you'll see, it's a very different looking scatter plot. In fact, we might want to change our our scale here, because time is going, let's look at time. The most we have is time here. It's going, okay, so we have 0.2, so that's not bad. So let's do the rest of them. We might need to go back and change our scale. So now we want to do, oops, not that one. We want to do the medium time and the medium velocity scatter plot. And let's look at that. So notice it's very different. It's not going up, which was showing us that our distance increased, right? As we were increasing our distance, our time increased, our total time increased. This is showing us our basic rate, our speed over that distance. And we're pretty consistent. So like, if you think about it, if we're just looking at the line here, the velocity is staying pretty constant. You know, if we had to put a regression on here, we would actually almost have a slope of 0. So let's see if the last one is sort of the same. So velocity is over time, it seems to be kind of constant. So let's do scatter plot for this last one. Now notice it's higher, right? Because our times were much faster because we were doing a hard push. But again, it still is pretty constant. You know, you got this outlier here, but it's pretty constant. So this is the difference. So this is a nice, like we could even pull this graph up here and compare it to the time distance graph. And so what's the difference? What is each one telling us about the push and the speed and all those types of things? So this is a really nice activity comparing those types of graphs for students.